everyone, and welcome to the last part of our conics unit, Unit 5A. Today we are finishing up talking about hyperbolas and a little bit more work with writing their equations. So we see here this supplemental note sheet that hopefully I remember to attach to Google Classroom that you guys may want to have, or if you just want to take notes in a notebook, that works as well. A reminder of these lovely formulas for our hyperbolas. Big thing here is A is no longer the biggest parameter, and the shape is going to be dictated by what comes first, your x squared or your y squared. And depending on that, that's going to dictate how it opens, either left and right or up and down if it's vertical. We also talk a little bit here about the length of the transverse axis versus the conjugate axis. And again, neither one, there's not really like a major or minor here because A is no longer, again, the biggest necessarily, so that's why they have these fun names. I like to think of them almost like major and minor since that's what we had with ellipses. And then we also talked about the equations of our asymptotes, which, again, these asymptotes that we kind of draw in help us dictate the shape of our hyperbola, and the horizontal one is y minus k, if we're looking for the slope of the line, equals plus or minus b over a is the slope. Since we're rising b, we're running a, and then x minus h. So again, if you're plugging in to find that, versus our vertical one, since we are rising a and running b this time, it's a little flip-flopped. So kind of using those information to move forward. Okay. And again, the other big changes, we said A is no longer the biggest parameter, C is. So in order to find those foci, we're taking A squared plus B squared, very similar to our Pythagorean theorem, to help find those locations of the foci. So our first example here has a picture, and we want to write the equation. So reminder, we're still dealing with a center point that this is all kind of hinging off of. And that's our h comma k value. And that's in this photo located at 0, 2. And since we're opening horizontally here, we're going to want to make sure that our x value is the one that is squared. Y is going to come second here, and then that's going to equal 1 as well. So we see again that our h value is actually 0. So something we can do here is just leave this as x squared eventually, and then while it's y minus 2. Now, the other thing, if we kind of look at the little drawn in box here, our vertices, aka where we're getting parameter A, those are located 4 units to the right or 4 units to the left of our hyperbola. So we would have 4 squared here, and then our B parameter is only 2 units. If we kind of look at the endpoints here, 2 and 2, so B would be 2 squared. So we write this so that it is a little bit prettier. Our final answer, we have x squared over 16 minus y minus 2 squared over 4 equals 1. Okay. So moving on to the back page here, we have a couple more examples. This one is looking to write the equation given the center, the length of the transverse axis, and the conjugate axis. Okay, well, our center, again, will be h comma k, and they're telling us that the transverse axis this time is vertical. So 2a, the length of that is 14, so a is going to be 7, and since it's vertical, we know that our y value will be coming first this time. X value is second, and then that's going to equal 1. And then we have here that h and k, reminder, go with x and y respectively. So it's going to be minus 6 here, and then negative 9 means minus negative is plus 9 there. So we have 7 squared here. And then we have, for B, since that was our conjugate axis, length is going to be double the length of the whole, it's going to be double the B value because we just want from center to a point on that conjugate axis. So 2B is 26, which means B is just 13. So 13 squared. So again, always simplify. So we would have the 7 squared is 149. Oh, sorry, not 149, just 49. And then the 13 squared was 169. There we go. That's our final answer. The next one, very similar to the last problem, actually. The vertices are actually, again, the length of our axis here, the conjugate axis, the transverse axis. And notice to go from 12 to -8, we moved a total of 20 units, right? Which means that our A parameter is going to be 10. Now notice we also moved horizontally, right? We moved the x values, which means our x parameter is going to be the one that's coming first in this equation, our x value, and y will come second because this is horizontal. And again, we would have 100, a squared always comes first. Now the conjugate axis this time is 18, which means that b is 9, b squared is 81. Last but not least, we were not given the center here, so we're going to have to look for our midpoint of the vertices because that'll be our center. So 12 plus a -8 is 4, divided by 2 is 2. And then we have -8 plus -8 is -16, divided by 2 is -8. So 2 and -8, which will turn this into +8 when we plug it in. Again, we are given an example this time that is not giving us our center. So again, we're going to want to find our center value by looking at the midpoint of these. Now, if we notice, -4 plus a -10 is -14. Divided by 2 is -7. 2 plus 2 is 4. Divided by 2 is 2. So we have our center. And notice on both of these, it's the x values that, again, are changing, right? We're adding and subtracting to the x values. So x will come first because this is going to be yet another horizontal opening hyperbola. And again, we can plug in h and k, so plus 7 minus 2. Now the vertices are a total of 6 units apart. So that would make our A parameter 3. And that always goes under the first term in our hyperbolas. And then this time, they're not giving us the any information about the conjugate axis. They're actually giving us the foci. Now, notice this foci are dealing with the C parameter, and we're adding or subtracting square root of 13, which is basically telling us that C itself is the square root of 13, which means C squared then is just 13. So in order to find parameter B, which is what we need here, write this a little lower, we're going to take C squared, and that's going to equal A squared plus B squared, what we're looking for. So 13 minus 9 gives us a B squared parameter of 4. Next one is kind of nice, right? We're given the center for once, and notice here we are changing again our x values when it comes to the vertex and the focus, which means yet another horizontal opening asymptote or hyperbola, which really should have varied up on that in these examples. So x squared, y squared equals 1. Now our center, h and k, are going to be 3 and -3, which minus a negative becomes plus. And our vertex, we had to move, for A, we had to move 3 units. So a squared is 9. And very similar to the last problem, in order to get from our center to our focus, we moved a total of 5 units, which means in order to find B squared, we have to take C squared equals A squared plus B squared. Subtract the 9, our B squared value is 16. Okay, last piece here is looking at some that are involving our asymptotes, right? So this first one is, again, not giving us the center, but we know that's going to be the midpoint between our vertices. So 8 plus -8 is 0, divided by 0 is 0. And then -2 minus, or plus -2 is -4, divided by 2, -2. Now notice, again, our vertices are moving x value-wise. So again, Miss Cechek really probably should have a little more variety so that we had more vertically opening examples. But again, x squared is coming first on this one. And what we're noticing then is that we're going to plug in our center. So x minus 0, y plus 2. Now this is where things are interesting. So remember, if we go back to this previous page, we said if it's horizontal, for our asymptotes, our formula is b over a, right? So when they're giving us the equation of one of our asymptotes, it's 7 over 8. That means we know the b value is 7, the a value, again, is 8 here. So, well, we have to care, well, hold that thought. Which we also could have found from the fact that our length here of 2a was also 16. So we could kind of deduce a two different ways, either using that distance or, again, b over a. In this case, we have 8 as our a value. So a squared is 64, always goes under the first parameter. B squared always goes under the second, 49. Okay. Now, this last type of problem, I think is personally the trickiest because it's not as direct. Like we just talked about, if we look here, that the equation of our asymptotes, you could tell your a and your b values depending on the shape of this. But it's actually going to go back to this perimeter of a rectangle. Now, a couple things. They're telling us, yet again, it's a horizontal transverse axis. So x squared is coming first. Again, my apologies. Carry this up in the future. And then they told us our center is at negative 10, 8. So we have plus 10 minus 8. Okay. Now, the key here is looking for the values of a and b, which are not as simple as one would think. It's not just going to be b over a again, because think about if you were drawing in your hyperbola, right? And perimeter of the central rectangle, right? We have this, opening, going to look like this, right? This is our hyperbola if it's horizontal. They're saying the perimeter of this rectangle is 84. If we tried to, let's say that the values, rise 10, run 11, that's not going to give us a perimeter of 84. This would be 10, this would be 11, right? The asymptote line slope. So this would be 11, this would be 10, which means the whole side here would be 22, the whole side here would be 20. Well, if we have this all up, we have to be careful. 22 plus 20 plus 22 plus 20, this one worked out that this ended up being 84, okay? But what if I had told you that the perimeter around the central rectangle was double that? Let's say I told you the perimeter of the central rectangle was 168. Well, this wouldn't have added up to 168, the perimeter of this rectangle, right? We would have, this would have reduced to be negative 10 over 11, but really what would have been happening is maybe we were rising 20 and running 22 to make sure that we had then a total length of 44 and 40 to get that total perimeter of what we needed of 168. Okay, now that's not the problem, but I wanted to bring to your attention because you will see examples where the perimeter of the central rectangle isn't necessarily what this reduced to be, right? If this reduced to be this, but these values could have been something different. Okay, so again, not 168, so I'm gonna get rid of that so we don't confuse ourselves. But in this case, we just had to double check. All right, so last but not least, a squared is 121, and then b squared is 100, okay? So be careful with these perimeter of the central rectangle problems because they may not work out exactly like that. Now, that was a whole lot of different hyperbola equation problems, but hopefully you feel better about those. And we'll definitely work more with them in class. Thanks, everyone. Congratulations on finishing comics.